Hello friends, today we'll explore two fundamental concepts in thermodynamics that are often confused in everyday language: heat and temperature. Although they may seem similar, they represent different physical realities. Let's start with heat. Heat refers to the transfer of thermal energy between molecules in a system and is measured in joules. Unlike what we might think, an object doesn't possess heat. Rather, heat is the energy in motion, energy that flows from one object to another. For example, when you place a hot object next to a cold one, the heat will naturally flow from the hot object to the cold one. That transfer of energy is what we call heat. Since heat is about energy in transit, it's classified as a process variable. Now, let's shift to temperature. Temperature, on the other hand, measures the average kinetic energy of the molecules within a substance or system. It's a measure of how fast those molecules are moving, and it is a state variable, something that describes the condition of an object. You can think of temperature as a snapshot of the energy level of a system at a specific moment. Temperature can be measured in Celsius, Fahrenheit, Kelvin, or Rankine. Here few basic differences between heat and temperature in terms of definition: see unit, symbols, particles, and ability to works. Now, how do these two concepts interact? This leads us to the second law of thermodynamics. Simply put, this law tells us that heat will always flow spontaneously from a hotter substance to a colder one. This explains everyday occurrences like why an ice cube melts in warm water or why you feel cold on a winter day. Understanding the difference between heat and temperature is crucial in thermodynamics as it deepens our understanding of energy transfer and the natural processes that surround us. Now, let's dive a bit deeper with a thought experiment that illustrates the relationship between heat and temperature. Imagine dropping an ice cube into warm water. The ice gains heat from the water, raising its temperature as the molecules move faster. However, when the ice melts, its temperature stays constant. Instead of increasing kinetic energy, the heat breaks the bonds holding the ice together, causing a phase change. Once fully melted, any additional heat increases the temperature of the water until everything reaches the same temperature, or equilibrium. This demonstrates that while heat usually changes temperature, during phase changes, it can be used to alter the state of a substance instead. Thank you for your attention.